So you might come across a problem that's asking you to graph and it has a fraction as the multiplier out front, okay, as that compression factor. Okay. If that's the case, and you follow the rules that we've talked about, okay, what you would do first here is you would plot your asymptote. Well, first of all, we look to see. It's a log graph, so is it going to be the left or the right? Log graph looks like this, so we're going to choose this graph. Okay, and we can plot our vertical asymptote is at 0, right? Okay, so that's the first step. Okay, once we find our vertical asymptote, we then want to let our input equal 1. So what value of x gives us an input of 1? Just 1, right? So we have 1, and then when we plug that in, log 3 of 1 is 0. 0 times 1/2 is 0. Okay, so there's our first point, so we can plot that, 1, 0. Okay, the next thing we want to do is plot our second point. Well, our second point is going to be where our input is equal to the base, in this case, 3. Okay, so when we let this be our input, log 3 of 3 has a value of 1. That's the rule that we chose, right? And then 1 times 1/2, so we have 3. And then we have 1 times 1/2. And so what's difficult to do is if you get a fraction here, it's because of the scaling of the graph. If you try to maneuver your point somewhere where it's 1/2, so like 3 1/2, somewhere around there, it's not going to be necessarily accurate. Okay, so what you're going to have to do on this is you have to find a different point that you can use for x. Okay, that's going to allow you to get rid of your 1/2 or to account for your 1/2. And the way that you can do that using some rules that we'll discuss in more detail is if you remember what the log represents. The log is the power to which the base needs to be taken to equal the number inside. Okay? So if we wanted, let's say we wanted this whole value to be a 2, because a 2 is going to cancel our fraction, right? You could make it a 3 or make it a 4 as well. But if we wanted to make this a 2, what we would have to do is it would have to be 3 to the second power is equal to what? 9, right? So if we were to think of log 3 of 9, that has a value of 3 to the second power is equal to 9. So we established that that was what we were looking for, the 2, and then we rebuilt it, kind of reverse engineered it. 3 to the power of 2 equals 9. So what we could do is we could use an x value of 9, and that's going to give us an output of 2. So log 3 of 9 is 2, and then 2 times 1/2 is 1.